I said in an earlier video we were going to spend some time understanding g of x as defined in the first fundamental theorem of calculus and used in the second fundamental theorem of calculus. Here we have g of x is equal to the integral from 0 to x. So a is defined as, or is identified as 0. So the integral from 0 to x of f of t dt, where f is the function whose graph is shown. Evaluate g of x for x equals 0, 1, 2, 3, 4, 5, and 6. So what I'm going to do is I'm going to set up a table of values. I'll put it here, I suppose. All right, so we'll do this as a table of values. When x is 0, we have the integral from 0 to 0. Of anything is going to be 0. Okay. The integral from 0 to 1. That's this much. And we go from the point 0, 1 to the point 1, 0 linearly. This is half of a square that has a size of 1. So the answer is 1/2. For g of 2, we're starting at 0 every single time. G of 2 says now go up to 2. But this first one is a triangle with an area of 1/2. The second one is below the x-axis. It's also a triangle with an area of 1/2, but it's got a value that's negative 1/2, right? So 1/2 minus 1/2 is going to be 0. The integral from 0 to 3 for g of 3 has a 1/2 here and a negative 1/2 here. And then we have another triangle that's half of a square. That's a negative 1/2 again. So if we're looking 1/2 minus 1/2 minus 1/2, that's going to be negative 1/2. From 0 to 4 for g of 4, I now have another triangle of area 1/2. And if you look, ultimately I've got 2 positives and 2 negatives. But really what I'm doing is I'm adding a half to this negative 1/2 because I started at 0 again. Anyway, the answer here is going to be 0. If all of that didn't make any sense, then maybe it'll start to after these next two. The integral from 0 to 5 of f of t dt is now going to throw in this 1.5 area, 1.5 squares, right? We have a square here, half a square here. So if we're looking here, g of 5 is equal to 1/2 minus 1/2 minus 1/2 plus 1/2 plus 1.5, right? And all of this added up to 0, and so the answer here for g of 5 is 3/2. For g of 6, again, all of that is still there. So in fact, I can just change this to g of 6. We are now going to add 2.5 to what we had already had. And 5/2 plus 3/2 is 4. So to recap, 1/2 was the answer for g of 1. 0 is the answer for g of 2. Negative 1/2 is the answer for g of 3. 0 is the answer for g of 4. 3/2, the sum of all that up to there, is the answer for g of 5. And then 8/2, or 4, is the answer for g of 6, okay? Now we're asked to estimate g of 7. The reason it's an estimate is because it's kind of curvy over here, right? So we have to kind of, guess. Now I've drawn here a line that goes from the peak of g of 6 down here to the point 7, 0. And the reason is because that is a triangle, and that's easy to work with. Triangle has a base of 1 and a height of 3, and so 1/2 base times height is 3.5. But then, is 3/2. But then we have this little part to deal with there. I'm going to say that's like 1/2. So here we're going to be adding like 2. And so we'll say g of 7 is equal to approximately 6. So hopefully that helps to understand this g, which is defined as an integral. And then we aren't really going to worry much about that moving forward. Where does g have a minimum value? So I'm going to look at all of these outputs, and it looks like Negative 1/2 is the smallest number over here. That occurs when x is 3. So where does g have a minimum value? At x equals 3. And you can see that that's where it's been as negative as it's going to be, like where f has been as negative as it's going to be, and everything after that is positive, right? And I misread that. So I'm answering minimum value there. Where does g have a maximum value? Sorry about that. Well, again, looking at all these numbers, the maximum value is about 6, and that occurs when x is equal to 7. So where does g have a maximum value? At x equals 7. And then we're to sketch a rough graph of g. All right, I have my grid here. And for some reason, folks find this to be difficult. Forget everything that just happened. Look over here. We have a bunch of points, 0, 0, 1, 1/2, and so on. And now we connect these with a nice smooth curve. Why does the curve need to be smooth? Because according to the fundamental theorem of calculus, g is differentiable. And there we are.